Okay, I wanted to show a quick demo of an interesting use of zero span in a spectrum analyzer. And to demonstrate this, I have it set up so that it can show the signal generated by an automobile key fob. And what's interesting about this particular signal is that it evidently involves two distinct frequencies. And what the key fob is doing is it's actually encoding data using those two different frequencies. It's flipping back and forth between them effectively. Let me restart it. To send zeros and ones. This is called binary frequency shift keying, or binary FSK. So it's effectively sending data here and then here and flipping back and forth. Basically it's modulating the signal to flip between those two frequencies rapidly in order to transmit the data. So what you may want to do is you may want to take a look at the data that this key fob is transmitting. And to do that, you might imagine setting up a system where you could set up a detector maybe at this frequency here on the left, and then view that over time. And it turns out the spectrum analyzer can help you do that. It turns out that with this particular spectrum analyzer, let me restart this again, if you set the resolution bandwidth to 30 kilohertz, just due to the timings involved and the way the spectrum analyzer is sweeping, you end up seeing effectively square waves embedded in the trace, in the signal that you're seeing. And what's happening here is as the spectrum analyzer starts to sweep from the left, it catches some of the power that's on that leftmost signal, and you can kind of see it. And as it goes across, the power flips on and off. The key fob is transmitting over here and then back, and you see this power rising and falling. So what you're actually doing is you're now seeing the data. So what you may then want to do is center the display on maybe that left frequency. Start it again. And then reduce the span so you can kind of zoom in on it, right? And then you're effectively having the spectrum analyzer trace over a smaller set of frequencies, kind of zooming in on that particular frequency. And in the limit, what you can actually do, you can just, instead of reducing the span down to close to zero, you can just tell the spectrum analyzer, you can indicate, I want zero span. And then it indicates zero span down here. And that's what it's now doing, is it's effectively holding its detector at, with this resolution bandwidth at the single center frequency, and it's spanning across effectively over time now, and it's behaving more like an oscilloscope, and that it's showing you information over time. And it's doing exactly kind of what you would want to do, is it's got a detector that's showing you that particular frequency over time. And as a matter of fact, you can change the sweep speed now. If I reduce it, it'll sweep across using less time, and effectively it's like zooming in on the signal. Let me restart it again. And with this, then, I won't show this, but you can use the trigger mode of the spectrum analyzer to trigger on these lines, and you can actually have it stop when it first detects that. And it actually really is behaving a lot more like an oscilloscope in that sense. So hopefully you found this interesting. All right, thank you for watching.